Okay, so I'm going to go ahead and go over the practice problems for Unit 7, Lesson 4. So this practice problem says that sleep researchers know that some people are early birds, represented with E, preferring to go to bed by 10 p.m. and arises by 7 a.m., while others are night owls, indicated with an N, preferring to go to bed after 11 p.m. and arising after 8 a.m. A study was done to compare dream recall for early birds and night owls. 100 people of each of the two types were selected at random and asked to record their dreams for 1 week. Some of the results are presented below. So the table shows us that we're given a mean, median, standard deviation, proportion, so percentage of people who showed no dreams, and a percentage of people that had 5 or more dreams. Okay. So question A says that researchers believe that night owls may have a better dream recall than do early birds. One parameter of interest to the researchers is the mean number of dreams recalled per week, with mu E representing the number of early birds and mu N representing the mean for night owls. The appropriate hypothesis would then be HO, where mu E minus mu N equals 0. This is the same thing as saying mu N equals mu E. And that mu E minus mu N is greater than 0. So that's saying mu E is less than mu N. Okay. State two other pairs of hypotheses using the proportions information given in the table above that might be used to test the researcher's belief. Be sure to define the parameters of interest in each case. So there's two ways that we can do this. Okay, and I'm going to erase some of this stuff so that I have room to write. There's two ways to do this. We can talk about the proportion of people who had no dreams, right? So PE equals proportion of early birds who recalled no dreams, or PN is the proportion of night owls who recalled no dreams, right? And in this case, scientists were saying that the early birds recalled less dreams than the night owls. So when we write the hypothesis for these, HO is going to be that PE is greater than PN, right? Because it shows that more people are not recalling dreams if they're an early bird. Sorry. HO is PE is equal to PN. It's always equal for HO. And for HA, PE is greater than PN because we want more early birds to not recall dreams. The other way, and the way that makes more sense to me, is that PE represents the proportion of early birds who recall 5 or more dreams. And that for PN, it's the proportion of night owls who recall 5 or more dreams, right? And then remember in this case, right, HOPE still equals to PN. But for HA, we're saying that PE is less than PN because more people who sleep at night recall the dreams. Use the data provided to carry out one of the two tests of hypotheses you have outlined in Part A. Then make a statement based on your findings on whether the data supports the researcher's claim. So I'm going to do where PE is the proportion of people who recall 5 or more dreams, because I want to know if night owls are recalling more dreams or not. So this is a 2-sample proportion z-test. And I'm going to split my boxes. I'm going to give myself more room for the conditions. So this is a random sample. The 10% condition definitely applies. 100 people is less than all the people in the world. N1 times P1 equals 100 times 0.55. And I'm saying that P1 is E. So NE and PE. So this is 55, which means that for failure, we have 45. And then for NN and PN equals 100 times 0.69. So that's 69. And then this side's going to be 100 times 0.31. So that's 31. So this meets the conditions for normal. Our parameters are up here already. So I'm just going to draw an arrow and write it here and rewrite our null. So PE equals PN. And then for HA, we're saying that PE is less than PN because people at night are recalling more dreams. Okay, for the math. We have P hat 1 is equal to 0.55. P hat 2 is equal to 0.69. P total is equal to 55 plus 45 over 100 plus 100. And this equals to 0.62. Okay. I'm going to plug in the numbers directly for the equation because I'm running out of room. So 0.55 minus 0.62 minus 0 over the square root of 0.62 times 0.38 over 100 plus 0.62 times 0.38 over 100. And this gives me a z-score of negative 203. Once I plug this into my calculator, I get a p-value of 0.02. So that means that if the proportion of people who recall 5 or more dreams for both groups are the same, then the probability of our sample difference or less is 2%. So this means that we reject HO and support HA. And in this context, what it means is that more people who are night owls are recalling 5 or more dreams. Okay. Next problem says that a large high school has been waging a campaign against drug use, particularly marijuana. Before the campaign began in 2004, a random sample of 100 students from the junior and senior class found 27 who admitted to using marijuana. To assess the success of their program in early 2007, they surveyed a random sample of 175 juniors and seniors, and 30 responded that they have used marijuana. Is this good evidence that the use of marijuana has been reduced at school? Provide statistical evidence to support your answer. So to make this a little bit easier for us, I'm going to actually just start by writing our parameters out because that helps me understand what my two groups are. So starting with my parameters, let P1 represent the proportion of juniors and seniors in 2004 who admitted to using marijuana and let P1 or P2 represent the proportion of juniors and seniors in 2007 who admitted to using marijuana. So remember that because it's a two-sample proportions test, P1 is equal to P2. And we're trying to say that P1 is greater than P2 because the proportions decreased in 2007. So let's go ahead and check our parameters, or check our conditions. So this is a random sample, and it's less than 10% of population. Okay. Now, is this normal? Well, in group 1, we have, so here's group 1, group 2. Here's our success, and here's our failure. So in our success, we had 27 students admitting to using marijuana, while 73 did not. And then in our second group in 2007, we had 30 students and 145 who says no. So we meet our conditions since all of these are bigger than 10. Okay, here's our math. Well, P1 is equal to 27 over 100, which is 0.27. P hat 2 is 30 over 175, which is 0.171. P total is 27 plus 30 over 100 plus 175. So this becomes 0.207. So Z equals 0.27 minus 0.171 minus 0 over the square root of 0.207 times 1 minus 0.207 over 100 plus 0.207 times 1 minus 0.207 over 175. Again, I just throw this into a calculator because it's easier to do the math than trying to do it, but you definitely can. We get 1.94. So then P value of this is 0.0262. So what can I conclude? If the true proportion of juniors and seniors using marijuana in 2004 and 2007 are the same, the probability of our sample difference or more is 0.0262. So since 0.0262 is less than 0.05, we reject HO, and there's evidence to support a decrease in marijuana usage. Okay. Last one. The National Sleep Foundation asked a random sample about their sleep habits. Split into two age categories, 26% of 184 people under 30 snored, compared with 39% of 811 in the older group. Does this difference of 13% imply that there's a significant difference in snoring between the age groups, or is it due to natural fluctuations in the sample we've chosen? So the fact that there's a significant difference means that we're looking at HA is not equal to, where P1 is not equal to P2. So again, I'm going to go ahead and create my boxes. And I'm going to start with my parameters this time, because again, I find it easier to do the parameters. So let P1 represent the proportion of people under 30 who snores. And let P2 represent the proportion of people over 30 who snores. So HO is that P1 equals P2. And then for HA, P1 does not equal to P2. So here's our conditions. It's a random sample. It's less than 10% of all people. And to check that it's normal, well, here's group 1, here's group 2, right? For success, we have N times P, so that's going to be 184 times 0.26, which is about 45 people, which means that for the failure, it's going to be 139, because it's just, it adds up to the total of our sample size, right? So we take 184 minus 45, and it gives us 139. Then we have N2 times P2, so that's that's 811 times 0.39, so that gives us 316. And then our failure is 495. So all of these work. So this is a normal condition. So here's the math. P hat 1 equals to 0.26. P hat 2 is 0.39. And then P hat total is equal to, remember, we're using the number of successes, right? So we had 45 success from the first one, plus 316 success from the second one, all over 184 plus 811, and this gives us 0.36. So to set this up, we got Z equals 0.26 minus 0.39 minus 0 divided by the square root of 0.36 times 0.1 minus 0.36 over 184 plus 0.36 times 1 minus 0.36 over 811. This gives me a z-score of negative 3.695, which means that my p-value is 0.0002. So, in conclusion, if P1 equals P2, then the probability of our sample difference or more extreme is 0.0002. Since P equals 0.0002 is less than alpha equals 0.05, we reject HO, and there's evidence that there's a significance difference. There's significant evidence to support that there is a difference in proportions for the two age groups, proportion in snorers for the 2 age group. Okay. We're going to do more practice next week on, or once we come back from spring break, on this material, so you don't have to